So we have just talked about the accuracy and the precision. Accuracy is evaluated by absolute and relative errors. The precision is evaluated by standard deviation and coefficient of variation. And what is the reason of the low accuracy or low precision? It is we have some errors. And in the case where when you have low accuracy, it means that your mean values are very far from the true value. In this case, the reason is some systematic or determinate error. Right? This is a systematic or determinate error. It will make the results consistently deviate from the true value in one direction. It means that this type of error will make your measurements always higher or lower than the true value. For example, if you have a chemical with some impurity, so the purity of the chemical is lower than 100%, and then the concentration of your solution will always smaller than what you have calculated, and so the results will be always smaller. And another example is, for example, if you have a pipette and the nose of it is broken, and the result is although the pipette is written with 10 milliliter, but you always take only 9.8 or 9.9 milliliter. So the amount of liquid that you take is always smaller than the true value that you want. So these are some examples of the source of a systematic error, and these errors can be overcome by proper calibration of instruments, so that it means that you check the accuracy of your instruments, your pipette, your balance, all your instruments and equipment. And another way to evaluate the impurity of chemicals, it is we run blank determinations. In these experiments, you will do the same procedure of analysis, but we will not add your sample. We just do the procedure with all the chemicals, all the solvents in the procedure, but we will not add your sample. And another way to overcome systematic error is we use another standard method. For example, if you use method A and we found the results to be 1.5, and if you want to know if is there any systematic error, so you will take some standard method that we know that it is very high, it has very high accuracy. And for example, if the result by this standard method is 1.7, so we know that the method A has a systematic error of minus 0.2, right? So this is another way to review the systematic error. The next case is when you have a low precision. All right, low precision means that your measurements are far from each other. In this case, you have high random errors, and these errors will make your results fluctuate. It means that in some measurement it will be higher, and in some other measurements the results will be lower than the true value. So the results fluctuate around the true values. This is the main difference between the random and systematic error. In systematic error, your results will be always higher or lower than the true value, but in the random for the random errors, your results will be around the true value. Some will be higher and some will be lower. And these random errors are always present in any measurement. It is unavoidable, but fortunately it is usually small, and we can evaluate the random errors by determining the standard deviation. Using the standard deviation, and these random errors can be lowered by increasing n, the number of experiments. If you look at the formula for SD, you will find that when we increase n, the standard deviation will be lower. The third type of errors is called blunders. In this case, you have very low accuracy and very low precision. Usually, the results will be very, very strange, ridiculous, and it's very easy to find that the result is nonsense, is not correct, and we eliminate. For example, you use the wrong reagent, or you write not correctly the concentration. For example, in some measurements, you need to use acid, hydrochloric acid, for example, but instead you use sodium hydroxide, right? So you use alkaline instead of acid, and the results will be totally different. And when you for example, when you write the correct concentration is 1.0, but you write 10, right? So the result will be 10 times different, right? Or if you have very wrong technique or sloppy technique, experimental technique, it will also result in a very strange value.